Hi everyone, in today's lesson we're going to talk about how to expand a binomial. So let's investigate by trying to expand these three binomials below. So x plus 3 to the 0 power. You should be telling me that that answer is 1 because anything raised to the 0 power is 1. Then we have x plus 3 squared. So what does it mean to square something? Multiply by itself. So this one is x plus 3 times x plus 3. And we can solve this by double distributing. So x times x is x times 3 is 3x, 3x times x is another 3x, and 3 times 3 is 9. And then, x times x was x squared. And then we can add these two together. So our final answer is x squared plus 6x plus 9. That wasn't too bad. Alright, let's see how we can do a binomial to the third power. Same thing as before. We're going to do x plus 3 times x plus 3 times x plus 3. So what we already know is this part. We know x plus 3 times x plus 3. That we can get from over here. So we could rewrite that. So that's x squared plus 6x plus 9. And we want to multiply that by x plus 3. So again, we're going to distribute. So x squared times x is x to the third. X squared times 3 is 3x squared. 6x times x is 6x squared. 6x times 3 is 18x. 9 times x is 9x. And then 9 times 3 is 27. And then now we can start by combining like terms. These are like terms, and these are like terms. So the final answer is x to the third plus 9x squared plus 27x plus 27. So that is my final answer here, and that is my final answer here. Now the question of the day is what if I asked you to expand x plus 3 to the fourth or x plus 3 to the fifth? It's honestly going to be too much work, and there has to be an easier way, because I could say x plus 3 to the 10th if I wanted to, and who wants to do this 10 times, right? So the first thing that we need to talk about is something called Pascal's triangle. And what it does is it gives us the coefficients of the expansion. So the way that it works is we start by writing 1, 1, and 1. And then what we do is we continue down this row of 1's in the diagonal and this row of 1's in the diagonals, and we add these two terms together. So watch, we're going to put this one over here and this one over here, and we're going to add these two together to get 2. And then we do the same thing. We bring this one down, we bring this one down. Now we're going to add these two and get 3. Add these two and get 3. Let's see if we could do it one more time. Bring the row of 1's down. And then we're going to add these two to get 4, these two to get 6, and these two to get 4. So what you just did was the coefficients of the expansion. So this one would be, the first one would be for x plus y to the 0 power. The second one would go for x plus y to the first power, x plus y to the second, x plus y to the third, and this one would be x plus y to the fourth, and so on and so on. So let's see if we could use Pascal's triangle to try to expand this binomial again, x plus 3 to the third, and let's see if we get this same answer up here. Okay, so the way that the expansion works is the first thing that we want to do is we want to write down, this is the first term, and then the 3 is the second term. So first, second. And the first term always gets the power, so x to the third. And then you keep writing down x to the second now, so you drop the power down, and then x to the first, and then all the way down to x to the 0. And then you take the second term, which is 3, and you write it all the way down here. And you just write the reverse. So if this starts at 3 and ends at 0, this one's going to start at 0 and end at 3. So this would be 0, 1, 2, 3. And then there's always going to be a number that we multiply in front, and that number that we multiply in front comes from Pascal's triangle. So that number, well, since I'm raising this to the third power, it's going to be this one right here. So 1, 3, 3, 1. So that's how we're going to multiply. 1, 3, 3, 1. And then we're going to simplify each of the columns, and we're done. So 1 times x to the third times 3 to the 0. Well, we could write down 1, and x to the third is just x to the third, and 3 to the 0 is just 1. Anything to the 0 power is 1, so we have x to the third. Okay, now we have the second one, 3x squared times 3. So 3 times 3 we can do, because 3 to the first, right? That'll make 9. And then we just have x squared. Then the third one is 3 times 3 squared. Well, 3 squared is 9. 9 times 3 is 27. 27x. And then we have 1 times 3 to the third, which is 27. And then x to the 0 is just 1, so 27. And then we just write it out. So x to the third plus 9x squared plus 27x plus 27. So x to the third plus 9x squared plus 27x plus 27. That is our answer, and it matches the answer that we had up here. So that's the binomial expansion. Now you're probably wondering, why would I use a binomial expansion for x to the third, like this problem here? Because we could have just double distributed or triple distributed, if you would, but the problems get a little bit harder. So let's look at a problem on the back. Okay, so let's use the expansion and Pascal's triangle for this next one. Okay, so the first thing that we're going to do is find the row here that matches with this power here. So this is to the 0, this is to the 1, second, and then third. So we've got this one right here. So we can start by writing that down. 1, 3, 3, 1. And now we're going to take the first term, the 2x to the fourth, and we're going to write that. 2x to the fourth, 2x to the fourth. Okay, and then we're going to take the second term, which is negative y, and now we're going to write the powers. Remember, the first power of 3 goes right here. So then it goes 3, 2, 1, 0, 0, 1, 2, and 3. So now what we're going to do is we're going to simplify each of the rows. So 2x to the fourth to the third, we're going to have to take 2 to the third, which is 8, and then x to the fourth to the third, we take the 3 and the 4, and we multiply them. So this would actually become 8x to the 12th. And then this y to the 0, or negative y to the 0, just turns into 1, and 1 times 1 will just be this 8x to the 12th. Okay, now let's do the second one. We've got 2x to the fourth squared, so we have to take 2 and square it, which is 4. So we have the 3 from before. Then we have 4x to the 8th power, because we're taking the 4 and 2 and we're multiplying them. And then negative y to the first is just negative y. Okay, then the next row is 3 times 2x to the fourth to the first, so that just stays. So we have 3, 2x to the fourth, and negative y squared is just positive y squared, because when we take the negative 1 and square it, we get positive 1. Okay, so this is 1. Anything to the 0 power is 1. And then we have negative y to the third. So negative y is the same thing as saying negative 1. So negative 1 to the third is negative 1, y to the third. So let's put it all together. So the first term, 8x squared, is just 8x squared. Now the second term is 3 times 4 times negative 1, which makes negative 12. So we have negative 12 x to the 8th, y. Then the next one is 3 times 2, which is 6. So we have 6 x to the 4th, y squared. And then the last one is negative y to the third. So that is my expansion of the original problem. Okay, let's see if we could do the next one, which is 3x minus 4 to the 4th power. So again, the first thing that we're going to do is we're going to find the expansion in Pascal's triangle. So this is to the 0, to the 1st, to the 2nd, to the 3rd, to the 4th. So let's go ahead and circle this one and write down all of the powers. So 1, 4, 6, 4, 1, and take our first and our second terms and write them out. So 3x, negative 4, and let's do that all the way through. Alright, now let's take the power. So remember, the power of 4 goes here. So 4, 3, 2, 1, 0. Then 0, 1, 2, 3, 4. So let's go ahead now and figure out what each row expands to. So the first one is just going to be 1 times, this is 1 as well, and now all this. So 3 to the 4th, and then x to the 4th. So we know that 3 to the 4th is 81. So we're going to say 81 x to the 4th is my first column, or first row. Now the second one is 3 times x to the 3rd. So 3 to the 3rd is 27, and then x to the 3rd is just x to the 3rd. So we have the 4 from the beginning. Then we have 27 x to the 3rd. And then we have negative 4 to the first power, which is negative 4. Okay, next we have the 6. Then we have negative 3 squared, which is 9. Then x squared. And a positive 16. Because when we take a negative 4 and square it, we get a positive 16. And then now we have 4 times negative 3x times negative 4 to the 3rd. Well, negative 4 to the 3rd is negative 64. So we have 4, negative 3x, and negative 64. And then we have 1 times anything to the 0 power times negative 4 to the 4th power. Okay, so we have just negative 4 to the 4th, which is a positive 256. Alright, now let's see if we can put this all together. So the first thing is 81x to the 4th. So I'm going to bring that down. 81x to the 4th. Now we need to multiply 4 times 27 times negative 4. So if you want, take out your calculators and type that in, 4 times 27 times negative 4. And you should get 432, but it should be negative because remember, we're only multiplying two positives and a negative. So negative 432x to the 3rd. Now we have the next term, which will be 9 times 6 times 16. Now if you type that into your calculator, you should get 864. x squared. Then the next row is 4 times negative 3 times 64, which will be a positive 768. And then the last column, or the last one, is just positive 256. So that is your final answer. Okay, so I'd like you to try these two for homework, and we will go over those in class tomorrow. All right, have a good night.